Properties of triangles. Working in trades, such as construction, requires taking many measurements. Using triangles, we know how to find missing sides and angles if we're given a right triangle. But what can we do if the triangle is not right? We want to talk about some properties of triangles. The first one is that the interior angles add up to 180. Well, what does that mean? Let's quickly sketch a triangle. Call this A, B, and C. Now, interior means inside. So angle A, angle B, and angle C. If you take those three, angle A plus angle B plus angle C have to equal 180. Well, that's kind of interesting. So let's just slap some numbers on this. Let's say that angle B is 30 degrees. Angle C is, let's just go 50 degrees. Well, now with this property, we can now calculate angle A. A plus 30 plus 50 equals 180. Do a little combination, 30 plus 50. A plus 80 equals 180. Solve for A. Angle A must be 100 degrees. The vertex is the corner of the triangle. So if you are using vertex as a vocabulary, you're looking for the points of the triangle. And of course, every triangle has 3 vertices. The base of a triangle can be any one of the 3 sides. Usually, we call the bottom side the base of the triangle. In my diagram, I might call this the base. But let's draw one. The base of a triangle can be any one of the 3 sides. Usually we call the bottom side of the triangle the base. So in this triangle that we just drew, this would be my base. In an isosceles triangle, the base is usually the unequal side. Remember, in an isosceles triangle, 2 sides are equal, the third one is not. The altitude, or height of the triangle, is perpendicular to the base, intersecting the opposite vertex. So an interesting triangle we drew here. Here is my opposite vertex to the base. This is part of the base, this is part of the base. So the height would be a line if I extend the base all the way out from the vertex straight down. That is my height. Let's try another one. Here's the triangle. Bottom one we'll call the base. The height is from the opposite vertex straight down. Now you'll notice that it's perpendicular to the base. When you make something perpendicular, you make right angles. Now that I've made a right angle, if I wanted to, I could use trigonometry on this triangle. So just some properties to think about. Let's flip the page. Your assignment will start by looking at types of triangles. We've listed 7 here. We can see equilateral, isosceles, scalene, right, and if I slide up, I've got acute and obtuse. For each triangle, draw a diagram. What does this actually look like? Be as accurate as possible, please. Define the triangle giving at least one property of that triangle. So what does it mean to be equilateral? What does it mean to be isosceles? A couple things you might want to do. We've already discussed the isosceles. We know the isosceles has two equal sides. So we can fill that in as our property for the isosceles. Let's draw a diagram. Well, our diagram needs to be very specific. How can we indicate that two sides are the same? What we do is we put symbols on those sides. I'm going to say that in my diagram, this side and this side are equal. Well, how do I show that? Draw a line and a line. That means that any side with a single line going through it are equal. How would I show that this bottom line is not equal? Well, I could leave it blank, or I could put two hashes through it. That would mean that these two sides are equal, but this one is not the same. Even though in my diagram, my sketch, it may look it, these symbols tell me it's not. One thing you will also know about isosceles triangle is that we have two equal angles. So in isosceles triangle, these two angles will be equal. Well, how can we indicate that? Put a symbol in there. I'm going to put a dot inside my angle sign, which indicates those are equal. So your diagram needs to be fairly neat, and it needs to have mathematical symbols to show what parts are equal, what part are not. You can complete this page for the remaining 6 triangles.